Let's deal with our next topic in light, and that is what happens when we get in light's way. Just as a quick review, we know from last time that light behaves like a wave, and sometimes it behaves like photons. Most often, scientists treat light as if it behaves like a wave. There are some instances, like when objects make their own light, that it would demonstrate this photon effect. So let's look at what happens when we get in light's way. We know that when waves run into a boundary, they're sometimes transmitted through it and sometimes reflected. So light behaves as a wave, and when it does, it can be reflected. Therefore, an object does not need to emit photons itself to be seen. It just has to reflect light back to our eyes. Objects that do not allow light to pass through it, we call opaque. Objects that allow light to pass through them, we call transparent. And objects that are somewhere in between, we categorize them as translucent. So our hands, for example, make great shadow puppets. And so when we're making these shadow puppets, our hands are acting as what kind of object? If you said opaque, you're right. So let's explain and understand these terms, transparent, translucent, opaque, and let's give some examples of how these plastic wrap would be transparent, wax paper translucent, and aluminum foil would be considered opaque. Why? Well, it totally blocks the light. Why is wax paper translucent? It partially blocks the light. And why would plastic wrap be considered transparent? Is that it totally allows the light to go through. So in vocabulary, transparent, materials that allow light to pass through; translucent, letting light through but scattering it; opaque, materials that do not let light through. So here's a transparent object, a window. Okay, this window, which has nice flat, straight surfaces, no bumpy surfaces on them whatsoever, is considered a transparent object. However, some windows, like frosted glass, which has pits and bumps in it, partially scatters the light. So any object that scatters the light, wax paper is another example, we call these translucent objects. And finally, any object that blocks the light and doesn't allow it to pass through, we would call these opaque. For example, the moon is opaque, as you see here in an eclipse. Our bodies, most parts of our bodies, most are opaque, like our hands. Aluminum foil is opaque. In fact, if you had to sum up objects, the majority of them would fall on the opaque category. When it comes to opaque, the other thing that we should remember from grade 7 science is dark, dull objects absorb light better than white, shiny objects. So when we did this experiment in grade 7, we found out that the black can got hotter and hotter and hotter than the white, dull can. Let's talk about more on opaque objects. When we shine light, a small light source at an opaque object, a shadow is created. And the dark part of the shadow is called the umbra. However, if we get a bigger source of light, we'll notice that we create two different kinds of shadows behind the object. The darker part is still called the umbra, but there will be a lighter shadow on either side when we use bigger sources of light, and that's called the penumbra. Also, what do we notice if we move the light closer to the object in regards to what happens to the shadow behind it? Does it get bigger or smaller? So let's say I want to create a big shadow. Do I move the light closer to the object or move the object closer to the light if I want to make a big shadow, or do I move it farther away? We won't talk about polarization. Let's look at this video clip about light to end today's session.
Dear BrainPop, I need to know as much information as you have about light. Particles, waves, reflections, refractions, and all that other stuff. Thanks, Nasli. Little bright, Moby. That spotlight is what you'd call an artificial light source. Artificial light is made when matter gives off energy in the form of light rays. This can happen in two ways. By heating something up until it produces light, like the wick of a candle, or running an electric current through a solid, like a light bulb filament, or a gas, like neon. There are also some natural sources of light. The sun comes to mind. Some animals can even produce light through chemical reactions. Light sources can emit a whole spectrum of radiation, only some of which you can see. When visible light hits objects, most of it bounces off. Your eyes catch this reflected light, and that's how you see. Light acts like a wave sometimes, but other times it can act like a particle. It's sort of its own thing. Sometimes it's helpful to think of it as waves, as vibrating electromagnetic fields. Other times, it's useful to think of light as discrete packets of energy called photons. Light can travel through empty space. The light that we see from stars has to travel thousands of years before it reaches us. And light travels fast. Well, it's so fast, it can travel 300 million meters in 1 second. Light likes to travel in a straight line through space, but when it hits an object, it changes direction. Hold up a mirror, and the light bounces your reflection right back at you. When light travels from one transparent material to another, it bends or refracts. The bending happens because light travels through different materials at different speeds. Light can travel a lot quicker moving through air than it can through glass. You can see this effect with a plain old glass of water and a straw. And that's how a prism works, by refracting different wavelengths of light at different angles. Lightning is an electrical effect that releases huge amounts of energy as light. You're such a baby. A heavy baby.